Hi there. My name is Rene Rubalcava, and thank you for having me here at HalfStack Online over 2020. I'm a software developer at Esri, and today I'm going to be talking about map phonics. And basically, how you can, another approach that you can look at or listen to data in your maps. So, how do we currently use maps today, right? Um, Pretty much people are using maps almost every day for things like getting directions, um, finding your favorite comic book store, searching for store hours or websites. I mean, maps have pretty much become a modern day search engine in a lot of ways. And there's a lot of different ways that you can find information for using maps. But maps can tell us so much more depending on how you use them. Maps also provide meaning to your data, right? The kind of information you would get from things like charts, as you can see here, it can provide another way to visualize that data and provide a new perspective on how you look at the data. And it's a way that you can go beyond placing points on a map, which is something that would be like the first go around when you start making a map. You get a bunch of coordinates, you put them on the map, and you can see where things are. But there's a lot more you can do with that. You can give some more meaning to those points. You want to find out what do they actually mean, right? So you can use maps along with the other tools to create these kind of like data reporting applications where the map is part of a larger tool set you can use to monitor some kind of information, whether that's static or information over time. That's a very popular way of doing things. Maps can also be used to tell stories, right? Um, Here's an example of a way that maps are being used to drive a particular story that is being told. In this case, about the mapping the ocean floors, right? And maps can be data driven, and when you combine that with storytelling, it provides a whole new look to the world that you're trying to show. So one of the things I've started exploring is how we can use something like the Web Audio API in web mapping applications to listen to data that is being shown on a map, right? And the Web Audio API, it's not exactly easy to use. It's a bit more of a complicated API. There's a lot of moving pieces, but there are libraries you can use to kind of simplify how to do things. So questions I want to ask were, how can I listen to the story of a map? If I have, when you're looking at a map and you're visualizing it, that visualization is being driven by most of the time, some sort of numeric data, right? Averages, statistics, summary data of some sort. How many people live in these certain areas? Concentration of people living in certain areas, right? So there's information in there, and I was curious how we can use that information to actually drive audio with the Web Audio API. And then the second question was, can I even do this? I've done a few experiments with it, try things out, and yes, it's something you could do. I mean, this is something you should do. I think it's a good experiment, and it's a nice and interesting way to look, or as I say, listen to data in the maps a bit differently. I mean, why would I do this? Well, why do we do anything, right? We're web developers. Do it because you can. So this is an example of how something like this might work. Like I said, the Web Audio API can get a little complicated. There's a lot of moving pieces. It's not that bad, but I found I really like using a library called P5JS, which is a processing library, but also has a sound module they can use with it. And it kind of simplifies the process, I thought, for me in quite a few ways to get this done. There's other libraries you can use, things like Tone.js that act very similarly. And I used the P5JS library along with the ArcGIS API for JavaScript to do the mapping part. Right, and you can see a sample here, this small snippet here, where basically I can load a sound file, and then I describe what I want the patterns for the sequence to be. And the sequence is basically, you know, in a step. Do I make the sound or do I not make a sound? 0 and 1s, right? The universal language. So that's kind of how you can set things up. So the sample application I want to look at today was built by a colleague of mine, Christian Ekenes, who built some really cool exploratory applications. He really knows what he's doing when it comes to visualization stuff. So when he provided this application for me, which is a COVID Explorer, which will essentially allow you to look at the number of COVID cases over time since January. It'll provide information on the active cases, the number of deaths, the number of recovered, and then I can look at those in time slices. So we can actually look on particular days from today to like 3 months ago, what the cases were at that time. I'm sorry, from like January to maybe like April, what the number of cases were and the statistics on that data, as well as be able to look at date ranges. So I could look at, for example, 2 weeks in July to see what the statistics were at that time. So it's a really interesting application. It provides a really interesting way to look at the data. There are different ways you can visualize the data. So I want to kind of tie that into the web audio API some way. So what I did with the application is I took the beats per minute, which is the common way that I'm going to look at this particular information, and that's going to be driven by the number of deaths in the data set, right? So from January to a particular date, how many COVID deaths were there, and use that to drive the beats per minute. So as you play the timeline, you'll hear the beats go faster from January, where it's like 1 death or 2 deaths, all the way up until today, where it goes by the number of deaths per 100,000. That's a lot of the counts in here are going to be taken this by per 100,000, just to make the numbers a bit more manageable, right? You can see a large number like 677,000, but when you see that it is a couple hundred people per 100,000, I mean, it's a bit more of an impact that way. There's also, when we look at date ranges, I'll use the numbers from the date ranges to drive the delay of the audio, which is going to be kind of the echo effect of the data. I'm sorry, echo effect of the audio that you'll hear, and that's driven by the attack, the delay, sustain, and release of the sound, right? Which is kind of if you can think of it like when you push a key, and you know how hard or long you push it, right? That's the attack, and then there's a slight delay, how long you sustain that signal, and then the release or decay of the signal at that point, right? So that's gonna be driven in here as well. So yeah, let's take a look at this application. Okay, so here we have a COVID application that my colleague Christian Ekenes put together, and it's a really interesting application for exploring COVID data. It'll basically allow me to visualize the data in a number of different scenarios. So for example here, on today's date, currently as of this recording, I could look at the number of active cases and visualize those on this map. I can go back to like a month ago to see what it looked like at that time. So I'm looking at a particular time slice. And I can go all the way back to something like the 4th of July to look at the number of active cases at that time, right? And I can do the same thing for maybe the density of cases. So if I want to see what where the density of cases is located at using a dot density renderer, this is equal to 1 dot is equal to 10 cases in the data, and the red is going to be active, blue is going to be recovered. So we're looking at July 4th here, and then maybe go back to a month ago. We can see we have a lot more recovered cases, and this is total all the way back from January. Then we can go ahead and look at maybe death as percentage of cases. So this is another visualization that we could explore here, and we could see that at a month ago, the percentage of deaths are going to be in a higher, this darker purple color over here, down to a lighter blue color. And then the total number of cases will be a large circle to a smaller circle, right? And we also explore it as ranges. So maybe I want to explore for 1 month. And let's see, this one's not too interesting, but maybe total cases over a month. So up to a month ago, maybe since Labor Day and all the way back to July 4th. So we can see what that looks like on the map. Maybe like since Sturgis over here. Yeah, right. So it's an interesting way to kind of slice up the data into dates or time frames, and gives us a way to explore this data set. So let's kind of look at how this is put together. An interesting thing to note is that the data this is coming from is not filled with numeric fields. There's string fields that need to be parsed. If you have this, I forget what this character is called, but a bar separator for the data. So it has to be parsed out to pull out the number of infections and the number of deaths from the data. And then doing all this work, it's a pretty large module that does an awful lot of work here. He was able to create these statistics that I'm going to be able to use to drive the audio portion of the application, right? So we've got number of cases, number of deaths, the active cases, recovered cases, and then the different rates per 100,000 that these apply to. So I can use this statistics data that is coming every time I move this time slider here to look at different time frames. I get new stats. I can use that to kind of drive the audio. And the way that's put together is I'm going to go ahead and load up P5.js. I have some default values here that I'm using for the attack, decay, sustain, and release time. That's part of the envelope that I'll be using to just kind of add a bit of an effect to the audio. I do create a reverb object, and we're going to explore how that reverb is being driven by the data as well. Let's come over here, just change this just a little bit. Let's go like active cases. There we go. And basically what I'm doing here is I'm going to load up my sound files. I have my pattern in here. So I have the bass playing on every fourth step. I've got a clap on every third. I have a hi-hat playing on the first and the first step. And then I've got a snare pattern playing, snare sound, playing on the second and the fourth step. And I've got 8 steps total for my pattern here. I can have as many as I wanted here. I can go, if I want to go up to like 32, 64, something like that, I could, or just 4 to make it simple. I could do that as well. I said just go for 8 in case, give me some wiggle room to adjust the patterns here. And I'm going to create my envelope. And like I said, this is to add some effects for the attack and the decay, sustain, and release time in here. And the P5 is really cool. It kind of gives you this nice documentation and the typings you can look at to get some descriptions of what everything is. And then I set my range. And then what I'm doing is I create these phrases, right? So the phrase is a way for me to play the pattern over time, right? So I have my, if the checkbox for one of these over here is clicked, I'll play my effects as part of my envelope. And and I'll also play, of course, the sound file. If I'm just gonna, if I don't have it checked, I won't play the effect. It'll just play the sound file by itself, which is how I get the effects happening in here. I'm sorry, this checkbox here is going to be this checkbox over here, right? So that when that's on, we'll get the effects playing as well. And I do that for the hi-hat, the clap, the bass, and the snare. That all behave the same. I create my part as drums, and it's just because that's what I'm used to calling something like this. I'd call it a drum pattern, even though I do have other things in here. But technically, this is a drum set because it's the hi-hat, the clap, the snare, and the bass, right? So it is a drum set, so I don't feel too bad about calling it drums. I set beat per minute to default 60, and this is going to change in a moment. And then I'm going to hook up my envelope to each of these patterns in here. All right. Each of my sound files. Then I'm going to go ahead and start the audio by clicking on this little button over here. And before I play that for you, I want to show you where some of this is actually updating. So when this checkbox is clicked, I will go ahead and create the reverb to initialize it to a new instance of a P5JS reverb, or I'll disconnect it. That means I'm basically going to turn it off. And when I do that, I need to adjust my time slider again. So that when I go ahead and I move the time slider to like a month ago, 2 weeks ago, or something, I make some change there. Then what I'm going to do is I'm going to go ahead and make some updates over here. So when we update the statistics, which is going to update this small information window here based on moving the slider around, I'm going to pull the same statistics and do something with them for the audio. So for example, for the drum set, I'm going to set the beats per minute equal to the death rate, which would be, in this case here, something like 55 beats per minute, since it's 55 per 100,000. I would do that here. I do want to set it if it's less than 0, which it would be sometime like in January, then I need it to be 1 minimum for the beats per minute, or some weird stuff starts happening in here. I think it's just a requirement of P5JS. It has to be a minimum of 1 or nothing. It can't be like 0.2 or 0.5. It's just not. Maybe it does, and I just couldn't hear it. But yeah, I had some weird things happening in that case. Then what I want to do is I want to take the active cases, divide them by cases times 100 to give me the number of seconds that I want to use for my reverb, and then also the decay rate. And I could play with this. I can multiply it by 10, so it gets makes it less. I'm just trying to get change the percentage into a real value that I could use here and apply that to the reverb in here as well. And I might not even need to do the multiply by 100. I liked it because of the way it sounded. And then I'm going to go ahead and set the envelope values here, which is going to be the attack will be active cases divided by cases. The decay will be the number of deaths divided by cases. The sustain will be the number of recovered divided by cases. And I have a default release time I'm going to use for the release in here. And that's how it's going to impact the audio. So if we play this now, I believe this should start playing. So this is without any effects in here. And I just start going over time, maybe jump ahead. So as you could hear, the beats per minute for the drum set, the pattern, increased over time as more deaths per 100,000 occurred in data. It's a pretty bleak enhancement to the data itself, right? So we have a visualization showing us these number of deaths growing on the map, and then we have the audio kind of speeding up to go with that. Then what we can do is we can also, like I said before, we can explore the data in date ranges. So like the last month, maybe since Labor Day. We move around here. Let's move this over a bit more. I guess something like no. So we're right around April, mid-April to late May or so, and we're looking at this particular time slice, and we're going to go ahead and now we're going to set this on here and turn on the reverb to kind of add another effect on top of this. That's the default. But if I turn on the hi-hat, for example, and maybe move this. So now we have that kind of reverb going on with the hi-hat, and I'll turn off the snare and the clap. We'll just play it. All right, so now we're really into some interesting effects happening here. Turn that off. And a lot of those effects were happening there. We heard that. It kind of went, I probably need to adjust some of these. Based on the, if we look at what we're doing here, we're taking it based off of the active cases and the deaths cases, and kind of, the decay rate kind of got out of hand there. Let's try it times 10, see what that is going to do. But it's kind of adding this overall enhancement to the visualizations themselves, right? So if we refresh the page here, try this again, make a little bit wider of a time slice. Move it. You can see that was a bit more of an ominous effect to the audio that was playing to go along with that. So it's an interesting way to use the Web Audio API and to kind of add another level of analysis to your applications working with maps. Similar to the way that maps could be compared as another visualization on top of something like charts, right? So you have charts and you have maps. You can have audio kind of working with that. I think the key there is trying to find a connection or a common ground in terms of what is represented with the audio to the map. So we're doing things like the beats per minute. We're doing things like the decay rates and the release times of the ADSR, so the active, decay, sustain, release time, adjusting the number of seconds for the reverb, all these different pieces that we're trying to just kind of tweak a bit and adjust to add a little extra on top of the map that we're already looking at. Okay, so to summarize, this application and combining the Web Audio API with the data visualizations, statistical data pulled from the map, it's completely experimental. I don't really have a solid use case to use it today, other than providing some kind of like interesting way to explore the data with the Web Audio API. I think it does provide some interesting things that might be possible when it comes in terms of accessibility. For example, the when you think about working with maps, the map itself is all drawn in WebGL, so it's a single context, and you can't really do accessibility on something like that, because if it were SVG, you could have the different SVG graphics could be accessible, but a single WebGL context element, I mean, it's not the canvas, it's not really something that could be accessible beyond maybe a description. But as you hover over the map and interacting with it, you kind of maybe want some more information out of there. And there are some things you can do, updating descriptions, stuff like that, I think would be interesting. But the web audio stuff could provide a whole new way to work with that. So I think that opens up some possibilities there. One thing I thought about doing as well is, instead of using samples like the 808 drum samples that I was using, maybe using tones. The Web Audio API, you can just have a single tone, and then you can adjust the oscillation of that tone and do some really cool things with it. So that's probably another way to try and explore the data as well. And then I just want to say thank you. Thank you for letting me present here today. Again, you can find me on social media at Odonet. And if you're interested in Esri or what we do, check out our career site. Thank you.
Thank you, Rene. That was amazing. I I don't want to diminish the quality of your awesome demos because they're so cool. But what I really want to see next time is a zombie explorer. What do you
Oh,
think
that's gonna be
would
a
be needed for
perfect one.
that? Yeah.
I'm sure I could map out like some cemeteries and figure out all the hot spots for zombie dangers. All right, so you may want to stay out of these areas in the outbreak.
That would be pretty cool. I mean, people joke that like the zombie apocalypse is upon us because of the combo of COVID and phones. So it feels fitting.
I mean, worry is just a matter of time at this point, right?
Yes.
I'd be screwed in that case. I've got 2 graveyards within 50 meters of me.
Woo. Yeah, my town just built their first cemetery this year. Like they didn't have
Their
one before.
first.
Yeah, they just opened one.
Oh,
They've relied on like other cities nearby for burial sites. They've never had. Well, okay, maybe they had one like 200 years ago, but they haven't had one in a long time. So,
I grew up across the street from a very old cemetery in LA that had like the full-on statues and mausoleums and stuff. And
yeah.
I mean, I grew up with this, I was fine, but nobody ever wanted to sleep over at my house. Just forget it.
Well, they'd watched Poltergeist, right? And they're like, no way.
I was like, what are you guys worried about? Come on.
I remember seeing that movie. I was fairly young, and it was terrifying. I mean, truly terrifying at that age. But oh man. So I noticed you have that really amazing Hackers poster.
Oh, yeah.
I like that. I don't know if we can see it in this view, but it was in your video as well. It was from HalfStack Phonics, and the reason I mentioned it is just like you've done a couple of talks before at HalfStack, but each time it's kind of different. But you really do this cool way of like using sound combined with maps. And if I remember correctly, you have a bit of a musical background as well, which kind of leads you to have this passion and interest.
Yeah, exactly. I mean, at one point, I was trying to be a music major with percussions because, if you can't play keyboard or guitar, any string instruments, they say major with percussion. So that's what I was doing. Then I needed a job, make some money. So I switched majors at that point. But I've always had that, kind of idea of that I've always wanted to do something with music in some way. So this was kind of a way for me to kind of dive into it and just bring kind of like 2 different things I work with and I'm passionate about together.
Yeah,
This is fun.
Which is that's kind of the HalfStack way, right? Like Tony has a previous background as like an amateur rapper and makes music for fun as well. Obviously Mina, who we saw do her live coding with music, and Richard Bultitude, who we've had speak before, does some stuff with like he tries to like make orchestral music out of demographic data and stuff. So it's not surprising. I think it's a really cool space that doesn't get much interest, and yet when everyone sees it, they're like, wow, this is amazing. So how would you encourage someone without a musical background to try to explore some of the things you do? Like how can they get started? And like you showed the Esri side of things, but like what musicals, like the low level, like intro to music theory stuff might help someone do something nice without, obviously it takes a lot of time to be good at it, but.
I mean, the basics you got to remember is that the beats and stuff like that typically work in groups of 4, right? That's why you have the old 4-track recorders, 8-track and up to 32 and whatnot and more. So you think about everything working in steps. You're going to play a beat or not play a beat is essentially how it all works. And the classic kind of techno thing is you'd have a bass, drum, and a clap and a hi-hat, right? And that's how you can start. I always like to play with that. The 808s. So if the 808 was a classic rolling machine for doing that kind of stuff to play with. So I really enjoyed those when I was younger. So I always dumped those in there. But yeah, you just start playing around with those. There's the some classic beats you can kind of work with, and then you just tempo. 60 beats per minute is kind of like the classic kind of techno beat. You have a bass every boom, boom kind of thing. And yeah, you start kind of there and then work your way from there and just figure out where things go. That's how you kind of experiment with it, play with it. And I like cool. P5.js. I think the sound modules they have P5.js just in terms of being able to load the files and play with the sounds and everything is really straightforward, easy to do. I did use Tone.js a little bit, but I just found P5 to be easier for me to work with in terms of libraries to do. Right. And I
Yeah.
tried the web audio API, and there's just so much you can do with the web audio API that I was getting confused here and there. I'm sure if I dedicate some time to it, it wouldn't be a problem though.
The web audio API is really nice, but it has some it's seriously complex and has some limits. Yeah. Tone.js is probably the best thing I've seen in terms of an attempt to clean up the web audio API and make it approachable. Whereas I think of P5.js as fairly general purpose processing of stuff, and they happen to do some stuff with music. So like you could get more out of Tone, but it's less approachable. So I get it. Yeah, it makes sense.
And they updated the TypeScript type things not too long ago, so it's really nice now to work with in TypeScript.
Yeah. Well, I'm a fan of TypeScript. In fact, I think you or someone from your team were the people who first asked me if I would consider using TypeScript. This was only after it had been out for like a month or two, and I'm like, you realize that's a Microsoft open source project you're talking about, right? Like that can't be real. And I mean, I gave a talk a couple months ago called The Rise of TypeScript, and I actually mentioned your team there as the people who introduced me to take TypeScript seriously, which is kind of funny because now I like help out with the TS-Conf, and I know the TypeScript team, and I'm active user of TypeScript and whatnot. So it's kind of funny how full circle things come sometimes.
And we just finished our full TypeScript conversion like maybe 2-3 months ago or so. Mm-hmm. So it took us that long to get all that stuff done.
Oh yeah, I mean it's a serious amount of work to like describe things in a way that are like comprehensible from a type system and ergonomic and usable, because there are certain things that are really difficult, so you probably shouldn't do those things to your users. You might do them internally, but you don't want to expose that as an external API that if you can't describe a type definition, like we went through that obviously with rewriting Dojo and whatnot. But yeah.
So I've got a question about layering the music on top of this map. Was it as easy as you thought to bring your ideas into reality, or was it a challenge to map what is quite a morbid set of data?
Yeah, exactly. Yeah,
something quite cool.
It was a little tricky at first. The tricky part was the data itself. The data isn't numeric by nature. They're string values, and they kind of have these common delimited separators per field. So you have like each day is a field, but it's got a string for the active cases, number of deaths, and number of recovered. So you have to parse that and then work with it. So I couldn't really run statistics directly on the data. So some of that stuff has to be done manually with JavaScript and everything, which isn't too bad. It would have been nice if I could have done it directly with the data set. But then from there, it's kind of determine what can drive what with the sounds, right? So like the beats per minute, you don't want to get something where you're going to end up like 500 beats per minute. It just gets a little, and I've done apps like that. And it's just, people are like covering their ears and stuff when that happens. So you got to kind of normalize the data to kind of match what you want to do with the audio a bit to get these kind of cool effects. So things like the attack and delay, sustain and release and stuff, those work in like anything under 1 percentages really. So you got to kind of normalize the data in that way and see what you get from there, right? Which is really kind of where the cool parts come in. And then when you start going over the data set in time, when you first run it from January, right? I mean, there's not really many cases going on. It's pretty slow. You're not even sure if it's working at first because you don't hear anything. And then all of a sudden things start ramping up, right? And then there's kind of this lull, and I can't remember what the months were, but where the number of active cases wasn't really going up too much, but then all of a sudden just kind of like boomed after a couple of months. Like they started going up again a lot. All right, so I think it's something we're seeing now again. Probably if I ran that, updated it today with the new data sets, we'd see a lot of big spike happening recently. So
Europe even more so. From the curves I've seen are pretty shocking compared to where they were even 2 weeks ago. Yeah.
And then when you're working with the COVID data, you always have to kind of be careful with how you look at it, how you're analyzing it and stuff, because you can tell the story probably in a bunch of different ways you want to. So you really just kind of want to treat the data with respect, right? You want to pull the data out, run your numbers on it, and the data is what the data is without trying to massage it too much, right? Which you don't really want to do. When I say normalize, I mean I'm just like dividing by 100 or multiplying by 10 or something to get values usable for the audio API. But I'm not massaging the data for anything. I'm just taking the data for what it is, right? And we've always been trying. I think a lot of people have tried to be careful about that, even since we've started making these kind of COVID maps. Is that you just want to present the data as is, provide the information without kind of trying to twist it in any certain way. Just it is what it is, and then you can interpret it however you want to interpret it, which you do with maps a lot anyway.
Yep. So thanks, Rene. I want to quickly do the final remarks and recap. And I think I don't want to it's hard to do back-to-back live sessions. So I'm just going to leave you all here while I do that real quick. It's just a minute. But after this, we're going to have a couple of replays of the amazing music sessions from the last HalfStack. It's kind of a nice way to unwind and wrap up the conference. But I just want to say thanks. It's always important to express gratitude. And I think it's really amazing that you all came together today. First of all, I want to thank all the amazing speakers like Rene and everyone else that was here, Tony and Joe, who were helpful in interviewing, and Joe's awesome talk, of course. Ashton from Mind's Eye Creative for the lovely visual recaps we have for each speaker. DHD for their help with design and animations and some of the video support. That's Siegel Bob, Tony's team, also for help on video processing and saving my sanity when you have to process all the videos that come in at once and make sense of them. Mina Marie for the lovely music that she made, both for the break, but also all of the background tracks for introducing all of the speakers and whatnot. The team at Vito and Vito itself for this lovely platform we have that just makes it a nice place to congregate and collaborate and have everything in one easy to use place that streams efficiently. Obviously, all the fun content and chat that everyone shared, our sponsors for making it viable to be able to do an event like this, because without their support, we would have to charge more money and we wouldn't be able to put on such a great event. My family for helping out with the videos, my son and my wife in particular, and all of you for attending. Thank you so much for making HalfStack Online 2 a spooktacular event, as someone said earlier. I like that. So thank you, and stick around for the music if you want. And otherwise, we'll see you at the next one in maybe May, maybe sooner. I don't know. We'll see. I haven't picked a date yet, which is, I usually plan way out in advance, but I kind of feel like COVID is not one you want to plan for too far in advance. So anyway, thanks. And
before we go, Dylan, I think on behalf of all of the speakers and everybody watching at home, thanks for pulling together another amazing conference for us all to enjoy. I know that everybody watching has really, really enjoyed it, and there's a hell of a lot of effort that goes into putting something like this. So thank you on behalf of everybody.
Thank you. Thank you so much, Tony. Thank you.